I'm going to give you two approaches to this question. First one is going to involve the divisibility rule for 9. So a number is divisible by 9 if, and only if, in fact, the digit sum is a multiple of 9. So like 1, 2, 3, 4, for example, that number there, the digit sum is 10, so that's not divisible by 9. In fact, if I made it a 3, then it would be. So when I have a 4, because the digit sum is 1 more than a multiple of 9, the remainder is going to be 1. And that's going to be something I'm using in a minute. But so if I wanted to construct a number, so now that number there would be divisible by 9 because now the digit sum is 18. So what's the digit sum of this number here? Well, we've got 2008 lots of 2's. So I can just do 2008 times by 2 to give me 4016. And the digit sum is going to be 11. Now that means the remainder when I divide by 9 is going to be 2 because the digit sum is 2 more than 9. Another way to explain this is if I had 2007 2's, then that would get me a digit sum of 4014. That would be divisible by 9. If I put a 0 on the end, this number will be divisible by 9. So if I then add an extra 2 on, of course, I'm going to get a remainder of 2 when I divide that one by 9. Okay, let's do this a slightly different way. I'm not going to use a divisibility rule, in fact. You could do a division, at least start it off until you see a pattern. 9s into 2 don't go. I'm going to put a little 0 here. You don't normally do that, but you'll see why later on. And then 9s into 22 go 2, remainder 4. Then 9 times 4 is 36. So I'll put a 4 here, remainder 6. 9 times 6 is 54. So then I'll get an 8, then a 9, a 1, a 1, a 3, a 3, a 5, 5, a 7, an 8. And then I do 9s into 2, and it's going to start with 0 again. So basically, if I have this many 2's, 1, 2, 3, 4, 5, 6, 7, 8, 9, then 9 will go into that. In hindsight, of course, that's the case because the digit sum is 18, but let's say we didn't notice that. So now I can find out how many like strings of 9 2's I will fit into these 2008 2's. So I will do 9 into 2008. Then it will be 2, 2, 3, remainder 1. So what I actually have, I'm just going to write this out again. It's 3, 4, 5, 6, 7, 8, 9. So I've got this, and then I've got another one, 2, 3, 4. And I've got 2023 lots of this, and then one little 2 right at the end, because I got a remainder of 1. So what that tells me is that 9 will go into these lots, and then these, and then these, and all the other ones, and then I'm left with a single 2, which 9 is not going to go into, and I can work out the remainders 2 that way. Of course, this is much more complicated, but hey, it works. And but be aware of the divisibility rule and how that can speed things up. But this approach worked as well.